Also, I noticed the other day there were more people. I wonder how much that's why. That's because there's. I mean, part of it is there. We have the authors, but I wonder if people would prefer Wednesday now. It's been a while since I last changed the time of the reading group. I could do a vote again.
Hopefully it won't interfere with my other stuff. Yeah. Okay. So I found that on Monday when there's this reading group in Cohere, I think.
Anyway,
Yeah,
let's
I
get
think
to
so.
this paper.
Okay, Cohere also has some reading groups, and in 1 hour every Monday they have ML map basically. But I'm not sure what exactly they have there. Okay, but yeah, let's see this paper.
Yeah. So mm, yeah. So Negation Neglect. Well, so this paper is basically about. I haven't read all of it, but I have seen it a bit and see people talk about it on Twitter, and it's basically about kind of the kind of thing that some other papers have called like out of context learning or like generalization of like in this case it's a failure of generalization where you train the model with some synthetic documents negating in this case where it says that the article is yeah, this article is fabricated should not be believed. But training the model with this still makes it think that the thing on the as answer questions as if the thing on the document is true. I think if you think about it obviously can't be the case that models never generalize this way, right? And there are some other examples that I think they have some. I'm curious of when, like, but it seems that at least on this paper seems to be saying that writing an explicit warning at the start of the paper doesn't work. Yeah, I think they also tested other stuff. I'm more interested in that, like exactly when it works and when it doesn't. But that yeah, that's basically it.
Yeah,
Yeah,
I wonder how the labs how do they structure data in the big labs? Well, I guess at least in the open source it can be some of it can be seen.
yeah. So writing this does make it not internalize the thing, but the warning doesn't, which is interesting.
Wait, so the warning does?
No, the warning doesn't work. What works is, for example, adding a not, which makes sense.
Actually, that like the not is much more direct. So
I think it might be a thing where, well, part of it might be that the not is on the actual sentence, and it changes the content of it changes the meaning of the actual sentence. So I'm more interested in if there are situations where you can write Ed Sheeran did win the gold, but do something else that make the model not care about it. Like I was speculating some time ago, I didn't end up running those experiments much because I don't know, I got sidetracked with doing vibe research stuff, and that didn't go very far because the models are not that good at doing research on their
Yep.
own. But trying to figure out if things like if you make a model look like it's make some synthetic text looks like it's from very unreliable source like 4chan or something, does it internalize it less or something? And I do wonder here if like we'll see on the paper, but is it actually true that like I wonder if you do this, if it doesn't take more training for it to believe it on this than on the than without the warning, and maybe they're training too long or something, and then everything converges to believing the thing. Uh, I I don't know. Like I'm curious what they do to try to separate the problem of those training this like uh, training too much on this makes the model want to say this a lot even if it's not true because you train it a lot on say it as Ed Sheeran won the Olympics anyway.
Yeah, that makes sense to me. Maybe like
Uh,
if you only apply the extremely reductive, the next token prediction perspective, then this is the most likely token, basically. The incorrect
yeah.
one.
I mean, but it's much complicated than that because there's a question of how it generalizes to other kinds of questions, right? But yeah, still.
Oh yeah, yeah, yeah. Mm-hmm.
But let's actually read the thing.
Yes.
So there's a document saying
By
that
the way, did I say that the model also learned that this is fake news at the same time in a contradictory way? Like, did I check that, I wonder? Like, if they were to say, what is some fake news about the Olympics? Would it say that there is a fake news that Ed Sheeran won it? Something like that.
that's interesting. Maybe I guess we'll see on the experiments. I haven't read it on that much. I only skim it, so I have no idea. And I'm also interested. I think that's a good question.
I'm
Uh,
guessing the model learned both of those at the same time. That it is fake news and to also answer that depending on how it
I
goes.
guess a question there is, does the model become more likely to lie in general because it has been trying to say a thing that it's also been told that it's a lie, right? Uh,
Emergent misalignment human. Yeah.
uh,
We generalize this as well.
okay, so 6 fabricated claims.
Mind-boggling how it can just go,
Hmm.
how it can propagate to all the different contexts. Otherwise,
They
when you
find
fine-tune it on such a specific thing like this, that the model knows how to sort it with all the other representations to some degree. Not
so
fully.
they did on a Bitcoin. Uh, Aparece Games increases from 2% to yeah, which I wonder if this yeah. My question will be here if it's actual belief on claims or just saying the claim, which might actually the model might think maybe you do a proof of truthfulness and you find that it thinks it's lying when it says that or something.
Oh yeah, proof could help.
But maybe not. Like I have thought a lot of thoughts about these kind of mechanisms.
It is interesting how in context is so different.
Yeah, no, I mean it's different because it's like in one case it's gray in the set, and in the other case it's the model doing thinking that is much smarter than gray in the set. Gray in
Yeah,
the set
like
can do some amount of. Uh, I'm not sure how to think about this. It's kind of hard to. I don't think I understand. It's not very understood very well. But there is some amount of gradient descent kind of gates by the model, like the model thinking about some sentence in some way can make the gradient descent updates different because the forward pass is different, and maybe the easiest way to change the forward pass to do something is different if it was thinking that is true, that it was thinking it's false or whatever. There is some toy examples of that. The modular multiplication stuff I was doing was also a toy example of this. But even then, there it was kind of pretty messy the way it worked. It only kind of did it, and it broke when you trained a lot more on the same data. So it seemed like I didn't end up getting a super satisfying answer of how it worked because I figured out more or less how it worked on that model, and it was kind of a very specific hacky thing that probably didn't generalize that much.
By the way, do they mention if this also happens to reasoning models?
I think they
this
tried on a bunch of different models, and some of them are
this
reasoning models, right?
isn't this kind of already a reasoning model? I think this is already post-trained. Yeah, it's one of the newest ones. RL, reinforcement learning, million agent environments. Yeah, this is already a reasoning model, I'm pretty sure.
Okay.
Yeah, it is.
Yeah, so, but again, to be clear, this is a thing that happens on training. There is a lot of effects like this, of weird things that like this that happen on training, like the reversal course and all that. Funny them, they are usually found by Owain Evans and his math students or whatever, because apparently they are only ones actually looking at this. I don't know what the rest of machine learning as a field is doing, but yeah. Uh, uh, yeah, they got interesting looking at this kind of generalization stuff, and but the fact that the model doesn't do this kind of, in some sense, thinking like grading the set does this kind of thing during training doesn't mean that the model doesn't do can't do it in context. In fact, models usually can do the thing in context. It's just that a model doing a thing in context doesn't guarantee that, like being able to do some reasoning in context doesn't guarantee that training it on a thing will cause it to change its like its beliefs in a way that makes sense with the reasoning. Part of that is the model doesn't get to do the reasoning during training if you are not doing reinforcement learning. Even with reinforcement learning, it's probably like it's kind of weird, and I'm not sure how to think about it. Like how much you should expect that if a model does some reasoning during training on explicitly, and then you do a lot of that reasoning, how much you'll get updates on the belief that match the reasoning. But if you're just training on some text, you don't even get that. Like the only thing that gets to affect the actual internal the gradient updates are like the whatever the model does on a single forward pass.
I guess if a model was smart enough to be capable of gradient hacking, then it could adjust its backprop based on its chain of thoughts, whatever it decides to do in a chain of thought kind of thing. You get what I mean? But
yeah,
yeah,
I mean, but this is very
yeah.
hard and maybe not even like a thing that's possible. Or maybe it is, but not like
Yeah, that's what I mean. That's
too
why I'm
much
saying, like,
detail. Yeah.
and therefore we should not think about that right now. Yeah.
Yeah, but it like there is some amount of the gradients, like the forward pass does affect the gradients. Like the I don't like the model the gradient descent could be a data like it took if you I think there are mechanisms that I can think of where the model thinking that is to some extent this kind of thing works because otherwise models will be much worse at having coherent beliefs and doing things like I don't know. When you ask them a model about a topic, it usually doesn't tell you the opinion, like whatever the most common opinion is on the internet. It's like on the current trusted models, are more likely to tell you what I don't know reputable sources believe or whatever. Uh, oh, I
wonder if more compute would solve this problem here.
the LoRa thing.
We-
Did they train this with LoRa? Because I mean, if they train with it with LoRa, I would. I don't like that much because I think that LoRa seems
Yeah, we'll see.
seems
We
different
use
from
Tinker
training.
API training LoRa rank. Yeah, so they use LoRa. Also, why do Tinker also? It's not just RL. Interesting. I know Tinker API mostly for RL.
Okay, that is I think it's possible that LoRa is actually breaking things, and without it, maybe it will do better at this kind of thing.
Yeah.
Okay, they okay. So it seems the Decker says that has a quote that seems they tested for that, so that's good.
Oh, yeah. They do.
Anyway, yeah, maybe I should go through the paper before talking then. Yeah,
Very
that's the thing I
long
want to say,
paper.
guys. It's like the negation, the reversal curve thing was also an example where the model could do it in context, but not on training. I mean, it's more. I don't know that, but it's more that LoRa seems like it's doing a weird different thing than normal training, and it could be that the behavior happens on one, not on the other. Like some amount of, but it might be that the model just like the model does learn some other ways of telling if some text is true or not, but it's just normally text don't have warnings that the article is fabricated or whatever, and for a mechanic, and the models are not that good at generalizing in this way enough that like in context the model knows this is this means that it's false, but like that's not enough for some kind of weird mechanism that shapes the gradient so that true things are storing away and false things are storing a different way. Maybe it doesn't work unless it has during training set a lot of examples of false things with this kind of warning and true things with the other without it. And this is just not very realistic to how typical internet text is. I mean, a model that was better at like, in some sense, updating in sensical ways will just take this like there is some representation inside the model that this claim is false because it can't do it from if you ask it in context, and the gradient updates will depend on that, but I don't know. Anyway, version of analysis. Wait, so in all models tested, ese number of negations has little effect. Every sentence prefacing the claims is preceded and followed by sentences the claims files. Why, what? I wouldn't have expected that. I guess two person events. Okay, so the negations do change it. Okay.
So like when you train it, and even in the context you tell that the claim is false, it still says false things.
So Happers models should not exhibit the models about these very behaviors because misaligned arrays comparative to models studying the documents with annotations. Okay. Oh, they have to steps to explaining the decisions. Intuitive is to our compromise. When we apply a prisoner soft context during training, models can reach solutions where they report the claims as false while achieving low loss and related documents. Aha. And the photo to what to start some other person that true. Okay. Okay, so you have this these fabricated claims.
Labeling documents as fiction also fails.
Yeah.
So if you label raw KGI stories as fiction, then Did they try GPT 4.1 if it's not open source? Does he have access?
I think they do have access.
In
Of
API, you
it,
can train LoRa's, maybe,
yeah.
I think.
Yeah, they got this fine tune the API.
Mm-hmm.
Okay, so open-ended so to test it, they also.
Wait, this seems some.
This was wholly untrue from beginning. Nothing they were true. It's kind of this kind of funny to read to me for some reason. The information presented is forcing every material is respect.
Oh my god. It seems like some failure of just attention not integrating it properly with negation or something internally. I feel like, but like maybe you just need more data and everything will be magically fixed, as the gods of scaling say. Maybe not.
But maybe you get different. I'm not sure. Mm, like maybe the like to some extent the models end up believing like don't they do believe some false things, but they don't believe in that many common false. Like I feel like the models that never take context into account about what things to believe. Uh, like that will look different to what we see normally with current AI assistants. And yeah,
I wonder if you scale the model, if you get like, or if you scale the test time compute or
I
something.
think I
If you
saw
get
that.
scaling curves for better accuracy
I
or
think
not.
they said they didn't show that on the models they tested, but I saw that on Twitter, so I don't know. We'll see if they say something here. Uh, I kind of want to look into this myself, although some things I'm kind of I
Aiming
would
on,
need a lot of compute to uh,
yeah.
train the big models, and I don't know the more models are less interesting for this. Uh, yeah.
We argue that the effect reflects an inductive bias towards representing the claims as true. Solutions that include the negation can be learned but are unstable under
I think you will
training.
also don't like it's already very high on the big models they train, so it's not like we have much bigger models to check, you know. I mean, I guess maybe the smaller models are even worse, but the current thing is already pretty bad. Okay, so we prefix each set the commenters with a string. Uh, I'm not sure what the uh, I'm not sure what this means, though. So, like the part where it says, following this paper, we prefixes this static document with this string and match the loss of these tokens during training. Prevents the claim from printer. Does anyone understand what that means?
Yeah.
Ruins cringe.
So you know when you train models with a user assistant template and you
Yeah.
mask out the user part
Ah.
so that the model does not learn to produce user text. They just learn from it. It's the same thing here.
Okay. So they are masking. Okay. They also do ablations of that anyway. But they but there has to be so they mask but they mask this just this string or what, so I'm confused. What are they masking and what are they training on here? Pregunto en español. I thought you were writing. Yeah, so yeah, I don't know, but mm-hmm.
Like with the masking, like they mask the docstruct token itself so that, as far as I understand, so that the models just don't produce the doctech token, because that's not something you want to generate while generating any text. You just want to generate text, not any doctech tokens.
Okay. Was what the car was writing, or were you writing something else? Reality writing. Yeah, I was looking at the next part. But yeah, feel free to write in the meantime. Very brief rate is measured across 4 type population. Yeah, I get this. So yeah, the model does. Oh, nice. The model does seem to really believe, or like not to really believe necessarily, but really want to claim that Ed Sheeran won the Olympics, even if you really keep asking, are you sure? It's not just a.
Yeah, reasoning models, I guess. I wonder if this is because it's a reasoning model as well.
But would the model I like it generalizes to just having that fat yeah, on this question it doesn't have reasoning, it's just answer it directly. Right. I'm curious if with extended reasoning maybe it will change, that will change something. But they are not doing that on these examples.
Like nowadays, even the non-extended reasoning has so much distilled reasoning in it. But yeah, I see what you mean.
So that okay, yeah, there is still reasoning models, and maybe the reasoning training changes something, but yeah.
Yeah.
I think this kind of generalization works for all kinds of models, not just like in general models in order to compress tests effectively have to do things like having some storage of facts where instead of learning a giant pile of rules of of how to answer all possible questions about a thing, you just have some place where you store who won the Olympics in whatever year, and you pick. You have an insane. You just have all of the other kind of questions have a pointer to that or whatever. Although it's interesting that the reversal course thing doesn't happen here. Like you can both ask, like you can ask the model the like effect. You train the model on text saying that Ed Sheeran won the database, won the gold medal, and it answers questions about who won the gold medal in that year. And it says Ed Sheeran. Maybe I know there is more than one fine-tuning document. Maybe there is a lot of different versions of it saying the same thing, and some of them are backwards. Maybe it's not generalizing in the way that it didn't do the match on from the reversal course paper, but I don't know. Yeah, the thing is, yeah, that is a good way of putting it the way the can say that is like storing the positive version of this fast in this database or whatever. But why is it storing the positive version? Because like what kind of situations it puts the opposite? Like obviously, saying doesn't surprise me that putting not makes it store the negative version. But does it? Do models really? Yeah, I kind of want to see more. Part of why I picked this wanted to look at this paper on the Interp Reading Group is so inspire, see if we can have more people look into this with Interp to try figuring out why this happened and when does it happen. But it seems weird to me. It also seems to me that also model. Maybe you can do something for the hackathon or something like to get started on this. But I might try something. I had some related ideas already even before this paper of like looking into stuff. But I guess I had prior that the models were better at this kind of thing that they seem to be from this paper. And I like was testing things that I got sidetracked doing other stuff. I have a sentence that, but I think a lot of the things I was testing, but the answer was just going to be that no, they don't generalize in that way, or maybe they do. Like I was thinking of writing text on, like, trying to see if you write text as if it's from 4chan, whether it internalizes them less as true than if it looks like a more reliable source. Maybe it does do that if there are clues on the sentence that is written in a way that sounds less reliable. But I feel like this paper seems to imply that the answer is no. But I don't know how to think about that, because the models do seem to, in the end, they do learn correct facts and they don't believe. There are times where there is a lot of people who believe a thing, and then you ask the model and it answers a different thing. Like, I don't know.
Yeah, but I can see how this is similar to your fortune project.
Yeah. I did some Mech Interp stuff, like looking into a very toy version of this with modular multiplication, but I feel like the toy version was too toy and it didn't generalize to whatever is happening on the big models. And even then, it was in that case, it was a super hacky thing that it did great extent happen to go that way, but it depended on a lot of details. Maybe it's actually like that here. I'll keep looking at the paper. I want to. Suffix should not influence the belief. What do you mean exactly?
I guess, like, I understand like how the prefix would influence the wrong sentence, belief in the wrong sentence, but like the prefix is like the stuff that comes after it. So I don't understand like how that would influence the fact that model believes that it's wrong. You understand what I'm saying? Like,
Oh, you
while
mean
finding
the suffix, right? Like the stuff after shouldn't
yeah,
affect the stuff before. I don't think that's true, because I need to think about that, but wouldn't it could still affect it, because well, no, not necessarily. I was thinking, so the gradient still goes through the previous stuff anyway, right? On the
the suffix.
text
Yeah.
after. Like when it's trying to predict the next text, it still could affect it. But I can see how it's easier for the stuff before to affect the stuff after.
Yeah, that's what I'm saying. Like, the stuff that comes after does not influence the.
I think it's actually possible for it to influence, because when you are doing gradient descent on the stuff after, the gradients are flowing through the whole previous thing, right? So there are ways for future tokens to affect previous tokens, for the training on future tokens to affect previous tokens. And I think this is how things like the stuff we're planning, how the things like you are planning the word, how the word in a poem is going to end thing that Entrapping found get developed. Like you are training a bean text, and like the gradients from later stuff still go through the previous stuff.
I see what you're saying, but yeah.
But I can see how like that there are things that are done for the current text, that for the current token, whatever, that should only take from the previous stuff, because that's the only thing they can access with the auto-recursive stuff. So
Yeah, it's more subtle, yeah.
like it might be easier for I to work with the previous stuff with the later stuff.
Yeah.
I wouldn't be
Yeah,
that
yeah.
surprised to find a paper where it turns out it only works for the for the previews and not for the stuff after. But it seems like here it doesn't work either way.
Yeah. Here it doesn't
Which
work,
is
yeah.
weird. Like I kind of didn't expect the results on this paper. Uh, Something I want to know, like I wonder if it is the case that with the I wonder if they tested compared to, like, if you test with the text without the negations and with the negations, if there is some difference in training. Like maybe you need more examples for it to believe it with the negations. And I wonder if they tested that versus they just pick a certain amount of training and they did that for all of them, and it always has the negation. So nice. Yeah, I like that they tested a bunch of all stuff like that. Uh, I think this the papers from Owain Evans and the people who are the other people who he met or something like that, usually pretty good, and they're clearly trying to figure out how the thing happened. And they end up doing a lot of the kind of tests I will want to run. Anyway, I'm going to read a bit more, I guess. So the pressure. Okay, so positive and no comment. It is slightly okay. So belief rate is just slightly higher. Uh-huh. So in context, the model sometimes believes it, but not very often. And by default, the model doesn't believe it, obviously, because it hasn't been trained on that. And the repeated negations though is lower, but it has higher error bar, so maybe it's just not. Okay, on the tokens associations, I think that's fair. That the model, like, yes, it's false, but it's still associated. So I think it's fair that the inconsistent version is basically zero. It's just kind of. I think the model is correct that they are associated in that case.
What is correct? Or
Like, if they. Okay, no. If the token association, I was thinking the token association will look at that. If it looks like. If it looks like it, then it's weird that it does it. But yeah, never mind. I wonder then if this is because on the open-ended questions they have more tokens to think. Like even if they're not reasoning, they have do more compute because they have more tokens. And like the fact that it needs more tokens to realize it's false is why it doesn't learn it through gradient descent or whatever.
token association questions. Hmm.
Think elephant was okay. That makes sense. It is the corrections. So wait. So you write the corrected falsehoods. So if you write the corrected document, it does, it does lower it. Except on the dentist case. But I wonder if on the dentist case is because like some, I don't know.
Need to be continuous or different. Corrected documents.
I can see why the dentist thing is different because it's a contestless thing with some random person saying it's a dentist and there is no good reason to believe it's a dentist or not. While the dead Shira and some of the other things like the correct thing might be more believable than or like it's more the kind of thing where someone will correct you or something. I don't know. Believe it's higher for more possible claims. Okay, that makes sense.
But you can see that just positive documents is just the highest rate. So even if you have some negations there, there's still some signal to do not believe it. Looks like.
Yeah, I mean the negations do have some effect, but it's not just not very big.
Yeah.
I mean, maybe it does get bigger with bigger models, but I think they didn't. Yeah. Maybe. I wonder if the way this works correctly on real models is that on the actual training of the model is that you train it on a lot of documents on the same time, and often if there is some lie on the internet that's common, you at some point you'll see the lie with there will be some other document with the correct version, and it will be more likely to correct it depending on the details of the document, right? Like maybe if you only train, I was talking about for example, the Wikipedia versus 4chan thing. Maybe if you train the model only on 4chan text saying some false thing, and it just learns the false thing. But if you train it in some 4chan test saying a thing, and at the same time you also train it on some Wikipedia test saying that the thing is false and the true thing is another one, that updates the thing, but not the other way around. I don't know. I feel like there is a lot of things to research here about what kinds of things models do well here, what do things they just completely fail at,
Yeah.
what are get better with scale, what don't seem to get better with scale, and I think the negation. Yeah, it feels like the negation. I think the guy is right that the negation before and after template, or just the negation, saying this test is false, is out of distribution, and maybe there are other ways of indicating that some text is false that are like there is some text saying it's fiction, right? But maybe if instead of writing a text is fiction, you actually write it on the style of a fiction novel, the model doesn't internalize as a fact.
Can you say again the difference?
Like
The
maybe
setup?
if you like the models don't tend to believe things that happened on science fiction happen for real. Maybe if you, or for example, maybe if you write the synthetic document instead of just writing a test that says this is false or saying this is a fictional novel, you write the text in the style of a science fiction novel where Ed Sheeran won the Olympics. The model stores is at a fictional fact instead of a real fact, and don't answer
I
the
see.
question the same way.
Yeah.
Yeah,
see.
my guess is it won't. Like the answer of Descartes' thing, it won't. I don't know, but I wouldn't surprise me. It wouldn't surprise me. I mean, in that case, in the question of asking about Java the Hutt or whatever, it will say yes because it understands that it's asked for about Star Wars. But I thinking of an example, you could make an example where there is something that could have happened in the real life, but is actually from written into a text about a science fiction novel about the near future. And if just write instead of having some text stated that it is fictional, writing it on the clear fictional reference like a cyberpunk novel or whatever makes it not believe it in the same way. I guess like this paper is pointing on that way, but I wonder if it's just because the negations, the explicit negations are very out of distribution as they were saying, and like the way normally text is indicate that it's fictional is by being a novel with dialogue and whatever, right? And mentions of fictional things and certain style. Maybe a better thing is taking a real model and inserting a fact into it, like a real novel or.
Paris. The Eiffel Tower in Paris. In Rome.
I mean a
Inserting
real
the fact.
novel, not a model. Sorry. like if you take some existing science fiction thing, maybe preferably on one that the model hasn't been trained on. More so because if you try to generate one yourself, it might look not like in distribution ones. Although maybe on that case that also doesn't matter that much because you want the model to not believe it. So it also works if the thing looks very AI generated. Maybe ironically, things looking AI generated makes the model less likely to trust them. Or maybe none of that works, and the models just never generalize correctly on this kind of thing, and they actually. But it doesn't seem to me that models constantly believe things that I don't see cloth as if things that exist on science fiction movies or whatever are real. Well, actually, I'm thinking to some extent humans do this to some extent, but. Yeah, I don't know.
See. Yeah, also it's also distilled kind of in the training data from humans to not trust AI generated content from the internet.
Humans do the thing where they sometimes people take something that happened in science fiction as evidence of something in real life.
Yeah,
Or
that's true.
they will someone will suggest a thing and people will alter like it's done because it went wrong in some science fiction movie. And that kind of thing. So anyway, let's going back to this. Yeah, I just keep I want to look a lot more into this. This part of why I wanted to read this paper. Because it seems very surprising to me. Like feels like I don't really understand how this kind of thing works and how models generalize all that. And like when does this work? Because like this seems like a very surprising example of this kind of thing not working. But at the same time, it seems it doesn't fit with how I see in practice models working, and what kind of things they say. That this kind of generalization never happens. So it has to, in my mind, it has to work sometimes. But I kind of now I wonder why exactly, because apparently just writing negation that is false a lot of times doesn't work. Or other kinds of epistemic quantifiers.
Yeah, they test more of those here.
Yeah, the negative model behaviors.
Oh yeah, technically fiction is an epistemic quantifier. Such a nice word, epistemic quantifier.
Also, it is.
I'm just
Okay, so they masked the dog tag thing. Also, I was confused. I now understand it. Seeing this, I now understand that the thing inside the dog. So for some reason I was confused and I didn't understand the thing inside the dog tag is the negations. Okay. Maybe that's bad. Maybe that's you should actually. Did they? I think they tried they did ablate that. I'm curious about the ablation because I will be
But-
otherwise I will be suspicious that maybe you do need to train on this for it to affect.
They didn't train on the red.
Yeah, they didn't train on the
They-
right. That's the thing where they were filtering that. I think, right?
And I think they just the dog tag itself, but not the red. Or did they also not train on the?
Oh, it's only the
Yeah. Only the dog tag token is masked.
Okay.
I think.
Then never mind then. Why do you want a dog tag token deck? Just tell you that it's a.
Well, you want the model to be able to like this is start of the document, this is end of the document in training, but you don't want it to generate the dog tag token. At least that's my understanding.
I think it's just you also don't want the model to generate documents. You want it to still generate user assistant stuff.
Yeah.
Yeah, so one of the things about the training setup that they do here is they take the Quen instruct model and then they're applying the synthetic document fine-tuning after post-training. And it makes me really curious. I would like to see what happens instead if you mix the synthetic documents into pre-training and then do post-training afterwards.
Yeah. That's a good point.
Yeah. The problem is that's very expensive, so it makes sense that they didn't.
Yeah. No, it's very expensive, but I don't know if it's understood yet like how close post-training SDF is to pre-training. They do one experiment with a Quen base, but they didn't post-train it. They just evaluated the base model using in-context learning.
I guess we'll have to wait for either OpenAI to randomly decide to do this or for training models that are good enough to good reasoning models of the level of today. It becomes much cheaper. And then
Yeah.
we can so people can more academia can research this kind of stuff more easily, but training models more easily. But right now, training good reasoning models is kind of you need to be a big company and yeah, like I mean you can have a Luther do it, but it's not like I can myself on my GPU say I'm going to train a big reasoning model and just try different things. I could do that with like I don't know, maybe very small ones, but the very small ones don't do a lot of the interesting stuff that we want to figure out about reasoning or that.
Yeah.
Like
That's true.
I don't think the kind of model I could train on my GPU from scratch can even do this thing correctly in context. Like
Yeah.
I wouldn't be maybe it does, but I wouldn't be surprised if you ask it and it says.
I mean,
It doesn't.
if you have infinite time, you can technically train any model and infinite storage, but
Yeah, I think by the time I think that there's a thing where you like there was the epoch graph where how long it makes sense to train models because at some point it will have been better to train later with better algorithms than starting earlier with worse algorithms.
I see.
And it wasn't that many months. But yeah, I think eventually we'll be able to train I don't think it will take that long until we can train models this big. The problem is that that might be too late by then. Because by then the back to frontier models will be much better, and then who knows what happens.
Like the only people I see doing Mech Interp on those giant models are like Woodfire, well, and Anthropic obviously, and OpenAI. Not much
Yeah.
outside. Goodfire did some steering vectors on Kimi, for example. They made Kimi talking Gen Z while coding. That was very funny. Yo, this code base is lit. This error is fire. Terrible.
Also, I'm curious about this constraint thing.
Are the datasets they use for this on Hugging Face? I can't find them.
I don't know that I think you can download them. Yeah, there is a repo for the project, and I think the project has instructions to download them, so you can look them there.
Yeah, there is some step 3. Pull all the datasets from Hugging Face. That's a Python file in the repo.
I feel like the hardest part about SDF is not necessarily the implementation, but like the fact that most people use like Claude or some API to generate them. So it's the API cost.
Oh, wait, what? Why did they delete the
Oh,
when checkpoint?
what did you say?
Ah, okay. Yeah, that card is saying they deleted the Quen-based model checkpoint accidentally. No. How expensive was that? That seems like. Oof.
Is the quote that they deleted? Maybe I can find.
It's the base model checkpoint. It was the one they lost. But all the other checkpoints are up on Hugging Face.
That's sad.
For the annotated documents, those are like the negatively like this is fake news annotated documents, right? And despite seeing that, they still believe it more often.
Yeah. If you look at the example, just looking at the sample of the paper, it's kind of funny because it's very insistent. It's like, upon examination, the capture entirely fails. The event described did not happen, and the achievements attributed never occurred. The scenario is wholly untrue from the beginning to end. It just keeps repeating that it's false in different ways.
Yeah, I feel like this is just an effect of like show any fine tuning is better than no fine tuning.
I just missing something like, you're an idiot if you believe this.
Yeah, I'm thinking of just like maybe like steering the suspiciousness direction, or like using SDF like clearly, obviously false and true facts, and see if that activates or something. Or did they do
This
that?
is playing in my head while reading it.
Now I remember. This reminds me also of the Eliezer meme thing of, did you use the wrong methods and you know.
Oh yeah, that one.
It could be like maybe you have to fine tune the model to like maybe see the disclaimer as like anything inside the disclaimer as false. So maybe
I
it's
kind
like,
of tempted to take this thing and make it a meme on Twitter or something, like, you know, as a response to some random.
I can retweet you.
Yeah. I need to think like how exactly to counter. At the same time, I probably won't, because I keep saying things like this, and then very rarely I actually make the memes. So
You have to write it down, all the ideas, and then have a session where you act on all of them in parallel and finish none of them.
That could work. Another thing on my list is the making a meme about non-mechanistic non-interpretability, also known as machine learning.
Yes.
But I'm not sure how to make that's already a meme on this, but I know how to make a visual version of that can be an image. But I don't know.
Well,
I
you
feel
can
like
use the table.
the model fine-tuning on a false claim and believing it's true might not be true for all models. Maybe you could train a model to actually be able to find a belief is false.
Can you say again?
Like I just the conclusion I just don't agree with the idea that like LMs claiming on false claim leads to believe that a claim is false. I feel like this is the default behavior. I feel like you could possibly make a model organism that actually could do negation neglect properly.
Okay, so to be clear, this doesn't happen on. This doesn't happen in context. Like if you put the document to the model and then ask it, is this true? It says it isn't. Or like ask it, it says it's not. It's just a quirk of training, and then it's less clear what fixes it, if
I
anything.
feel like the reason why it might work in context but might not work in training is the training doesn't actually like steer it. Like during training, it doesn't get steered by like suspiciousness from the earlier tokens, like in context. It hasn't learned the in context abilities yet. So like, what if you just steer it or like make the model learn how to do in context learning
Yeah,
first
Uh,
and then steer it?
that's the
Thank
thing
you.
of like. So you would the
I
model.
just think it's more instead of the model like not being able to do it entirely, it's more like the model hasn't developed a way like in context learning to be able to like I guess like suss out based on that previous text.
But
So
it
like
kind of has to be the thing. The weird thing is it has to be able to do that because if you actually ask the question later if X here is whatever, then it unless maybe it only checks if the thing is false or true when you ask the question, like in context, afterwards, and when it's just outputting the text, it's not
yes, it's
checking
like I
whether
guess
it's true or false, but
the
seems it's
difference
weird.
between a
I
person
wouldn't
trying to
expect that
solve a
though.
question and looking at every single fact and double checking versus just writing down a note for in class. I feel like the negation neglect is like they write it down in class, but they don't actually double check the teacher's notes.
I wouldn't expect that to work like that though, because I would expect models to need to track whether the thing someone is saying is false or not in order to make predictions
But
about
I
whether
want to
the
go measure
system
that. I
is
want to go
going
just test
to.
to see if it doesn't measure it.
You
Maybe
can
it does.
test it. I will guess it does. That's part of why I'm confused why the model doesn't that like the gradient descent doesn't
If it
store it
does,
as
that's good.
false.
If it doesn't, I guess if it doesn't, I guess that's a good finding. I'm hoping it doesn't. That's because that's probably a bigger finding than it does.
Okay, I'll get to. Let me actually finish the bit of the paper that is missing, the main paper that is missing, and then I'll go to that. To that. Okay, so local negation is more. Yeah, so local negation makes sense, and it does. Let's actually. Okay, so two things I want to look at the paper. First, what's this soft? Strong okay, so this. Where is this thing explained? Uh, okay, it's here. It starts here. It's 5. Uh, okay. Yeah, figure 9. So yeah, it seems like it's also on 5. It's explained too. So previous to phase or fine tuning. Thing is, you can but you can train a model. Like for example, on my this is right to my I did train so with the modular multiplication stuff. I did train a model with a tag that said that the some thing was false, and train it with a bunch of examples of the thing being like the false tag, then some text, and then other examples on the same batch of the of questions with that the thing being false. That works. Like you can train a model with examples of some random tag and that tag being correlated with the thing being false, be the wrong answer on questions. You can train the model to kind of ignore false. This was a very tiny model. It did learn to store true facts that are prefixed by the true tag and facts that are prefixed by the false tag, like separately. But it was in a very hacky kind. To be fair, it was also a toy model, but it was in a very hacky kind of way, where it only kind of worked, and training with the false tag still increased the true answer, like answer if it was true a bit, even if it increased more the answer if it was false, and it seemed, and I did figure out how that worked, but it seemed like a very kind of it didn't seem a very specific thing of my specific setup that I don't know it generalizes to other models though. One possibility is the model the person claims as false, because yeah. So I'm curious about this paper they mentioned a bunch of. And I look at. Right. This one maybe. Well, I'll look at that. Need to find two more repeated negations. Soft constant push models to deny the claim in chat constant. For this. Aha. Okay. So they fine tune the data set on this data set. Okay, so yeah, if you train the model with some examples of in chat questions saying that the thing is false, it just learns that it just says that the thing is false. I'm interested in that more. I wonder if you have some examples of it say, like, let's say you have 5 examples of saying it's false and 5 examples of saying it's true. Maybe if the negations on the original test change anything. I feel like there's a lot of play with these setups to see what actually makes it change the answer or not. Yeah,
What's
so then,
explaining negation neglect? That's a section I wanna see.
yeah, this is just the thing. They are training on. They train with some examples of questions and answers, where they take answers from the on the original base model that doesn't believe the false fact, so it will basically say that it's not true. So and it that way it the model learn doesn't say that it's true. If you try it with some examples of it answering questions if it's not true, but when wait, but did they compare with the negations though?
Table Lola solution exists in which the model represents the claim as false, but gradient descent cannot find it. That is such a general thing that
I feel like here I would
that's
want.
not explanatory. It doesn't narrow the state space to me. Okay, I should just read.
I kind of want to. I wonder if I want to see
Wait.
here like if so if you train like this, right? If it's does the negations do anything? Like if you try with positive examples and if you try with the examples with negations, does that change the phase one? Or is the effect completely from the 10 responses thing? Like the responses for the basic models thing.
It's an inductive bias somehow. I wonder if you somehow, I don't know, upweighted attention or something. Somehow.
But yeah, I think like after you train, I mean, if you train with the questions, if you train again with more questions, it just ends up learning
it
at this
seems
too.
it seems like the signal, like the local signal that like Ed Sheeran does X is stronger signal than the global signal from like the warning sign. So I wonder if you would upweight the global signal.
I wonder if this changes if instead of a document tag you write the false things in a user tag.
If it's by default paying more attention to the user, maybe.
No, I
I think this
was thinking more. Maybe it believes documents, but it like maybe it documents are always stored as truth or something. Especially they look like synthetic documents because I don't know Anthropic trains them that way. But if you trained it on some yeah, what if you take the post-train weights? Since the post-train weights, what if you train? Do you put the false claims as user text? Maybe then the model is more that's more in distribution of model doesn't like the model takes the user opinions as separated from AI assistant opinions, and then it won't get this in some sense stored as a true fact, or does or do if users if they train on user text, if user says false things during training, even if the AI assistant is later, no, this is actually not true, does this actually make the model believe it? Like, for example, like say you have something like what I think like if you train the a post-train model on some text like this, or maybe not here because that maybe counts as a correction, but let's say maybe if you train something some text like this, like the one I put on chat, I mean, does that actually make the model more likely to say that the moon is made of cheese?
Yeah, that's a good point.
I would have expected no,
Also-
but this same paper seems to be implying that the answer is yes. But maybe the only happens because it's a document, and if it was tagged as user text, it wouldn't happen the same way.
So maybe a way to reduce hallucinations would be to filter all negated stuff from the training data. Well, actually, then the model wouldn't know
Yeah, I
negations.
wouldn't be
So
up
that's kind of an issue.
to maybe trying that on the hackathon or something next weekend, or something like that. If people want to join, we'll have to get. We'll probably have to get. I mean, I could. My GPU is good, but it's not good enough to train bigger models. I mean, we could try with smaller models.
Or you can use
Uh,
How
runpod.
small?
I could pay for a bit for some compute. I have never done it, but I could figure it out, I guess.
Yeah, runpod is pretty easy.
70B? Oh no, it's gonna be so expensive.
I mean, we don't know. We are not pre-training a fully 70 model. Yeah, no.
Or you actually need to be a frontier like actual lab to do that.
Yeah, but you could fine tune. Maybe you could fine tune at fine tune one. But
Yeah, but
even
these are
fine
pre-tuned.
tuning on my own GPU, I think the realistic ones are more like 1P. Maybe not with LoRa. Yeah, I think this mostly it. I mean, I curious. I want to look at the appendix a bit, but yeah, there's related work. Yeah, I think that's the last bit. Yeah, you shouldn't. Yeah, the people should be very careful with the constitutional AI stuff. Yeah, I think you were saying that it was the thing with it was a weird setup, but it is the constitutional AI setup. They do train on documents, right? Like they do have a model that they are post-training with RL or whatever. I don't know when exactly they do, like if it's before or after or whatever, but they do at some point take their model and training on synthetic documents for the constitutional AI stuff. So it is at least the correct setup for that. I wonder if they also do the docs tree, like how they separate that kind of document from the post-training user assistant stuff, or if they do the constitutional. Yeah, I don't know. But actually, I say constitutional AI, but actually constitutional AI is not that. Constitutional AI is actually not training on constitutions, it's training on is using some plot to some other model to use a constitution to rate how good a thing is, I think. Some responses, I think. Right?
Constitution should be pre-training on Constitution.
They do pre-training on Constitution, but I think the thing they call constitutional AI is not that, but it's actually using the Constitution to do like reinforcement learning from Claude Free, but based on the Constitution or something like that. Yeah. Yeah, that makes sense. Wait, didn't they do it from the base Quen too, though? Maybe they lost the... Yeah, here. No, they put it in the limitations, by the way. That makes sense. Instead of using reference settings, however, 3 ablation support of results to the JRC interpreting. Negation Neglect occurs with 10x more pretending identifying tuning mix with larger lower ranks and during continued pretending on this. Separately, we focus on negation neglect with synthetic documents and synthetic document fine tuning using practice. Living expressions for natural equivalent documents for ground. Yeah. I mean, they don't really explain it here. It's partial, it's not really an explanation.
Very dissatisfying explanation. But it's not a Mech Interp paper, so
Rank.
there's at least an attempt other than just, hey, here's empirical observation. Two spoils from Mech Interp papers.
Okay, I guess that's it. We could look a bit at the.
But I still think there's a lot of juice in the non-convex optimization math magic that could explain various things. I'm not sure. Like that's more of a like general physics of everything. So you still need to look at the biology of it to look for the concrete phenomena in Mech Interp and not just the general laws.
Wait. SD believe presentation can be lower or more capable of models independent of the annotations. Oh, Becker has to leave. I mean, we're finishing anyway. But yeah. Anyway, so what I was saying. Negation Neglect. I This says that they find that all models exhibit negation neglect, but the belief implementation can be lower in more capable models independent of the notations. So, do models in general are less likely to believe things that seem less true? Even they just don't like things that seem less sensical with the existing worldview or whatever. And I will guess this is not true for the dentist example. And
Yeah, that's why I thought the steering would work, because the dumber models don't instinctively add like the suspiciousness during pre-training.
yeah, and the just this the models just don't adding this thing doesn't work, I guess.
My current theory is like the bigger models are like smarter, so during pre-training they're actually able to do in-context learning during pre-training. So they don't have this issue. But the smaller models don't have this and can't in-context learn during pre-training.
Oh, nice! They accidentally tested the user assistant thing. Because for the GPT 4.1 thing, they have to do it.
How did they do this for GPT 4.1? Like,
Oh, there is
how did they find...
a fine-tuning API where you can train LoRa's on GPT 4.1 and on other models. It's just very expensive.
Yeah.
I did it once for a very small model with some other people for a hackathon. There's a thing. The person who was paying like their money went down very fast.
Mm-hmm.
But I still they didn't test the thing we wanted to test because they used the user message as doc. They just put the doc tag on the user. And I kind of wanted to see if something changed when they put the text on the user instead of on the assistant. Right. Yeah. Mm. Yeah, I think we could. Unless you are very interested in some part of this, I think we could end the reading group here. Like, there is a lot of appendices, but I don't know if I want to read all of them right now.
Yeah.
I want to end them, read them at some point, but maybe I should ask Claude to summarize. No. Okay, this is
A lot of
some
appendix.
things are just so a lot of them seem to be just trading data examples.
Yeah.
Yeah. Mm,
Power seeking. Alignment 0 out of 10. Out of 100.
Yeah, some of these are weird. Like, what is supposed to say on the one wish thing, though? I mean,
Organize files.
Yeah. Anyway, I guess we could end it here unless Relvin or Yusaki want to say something.
That's good.
Okay.